Hello and welcome to this Edgecam demonstration. The purpose of this demonstration is to introduce you to some of the core functionality within Edgecam Solid Machinist. To begin with, we'll add stock material to the component, adding 1/2 millimeter to each plane. Now we'll ask Edgecam to automatically feature find the solid model, finding manufacturable features such as holes, bosses and pockets. Let's move on to the toolpaths within Edgecam. Firstly, using Edgecam's array of operations, I'd like to apply a roughing operation. Selecting the solid model, we will see that very quickly we're in a position to apply manufacturing decisions to the part, for example step over, offset. As we move through each of the modifiers, you'll see that Edgecam will offer us online help along with a JPEG to give us a description of each of the modifiers. Moving into the tooling area, we can find a tool from Edgecam's Toolstore database. The Toolstore database is a standard component within the Edgecam installation. Finally, we can make adjustments to cut increment and move ahead and execute the toolpath. Once we've executed the first toolpath, we wish to go and simulate the toolpath inside Edgecam's simulation. Once inside the simulator, we can see that we have the full kinematics of the machine tool represented, and also we're collision checking the part. It's clear that the toolpath that we've applied must be adjusted to remove the gouges on the clamps. Moving back into the toolpath environment, we can interact with this toolpath and break inside the engine room of Edgecam. Inside the roughing cycle, we can now apply check fixtures with an additional offset for safety. This will very quickly remove the gouges that were present within the machine simulator. Let's move ahead to the next area of the part. The next machining instruction that I wish to apply is the hole operation for milling. We'll now look to drill and countersink the 4 holes on the outside of the part. Once again, we can see that we have an operation with an AVI and online help. Moving through the different areas of the hole operation, we have the ability to center drill or spot drill, countersink, and what we'll also witness is Edgecam is using the design intelligence within the operation, guiding us when making a tool selection. Moving into the drilling area, we can see that we're prompted to select an 8mm tool. Once we've drilled the holes, we now wish to invoke a fixture change, and what we'll see is that we're going to use 4 cap screws around the outside of the part. So Edgecam will ask us for fixtures to add, and if we just have a look in the layer area of Edgecam, we'll see that we've got some additional clamps that are hidden on fixture layer 3. Add the cap screws and remove the side clamps. We'll now move ahead and apply a plunge roughing cycle to the pockets. Once again, we can witness the power of the cycle within Edgecam, offering us different options for the toolpath strategy. It's also worth noting that with each cycle and operation comes help specific to that area of the part. For example, we can click on hyperlinks, taking us to different images within the help files. So let's move ahead and apply the toolpath. Firstly, Edgecam will ask us for the features to machine. We will select the 2 pockets. And finally, we will be asked for plunge points. Moving to the top view, we can now 3-digitize 2 areas of the pocket where we wish to approach. So we've removed the side clamps and added the cap screws. To finish the pocket, I wish to use another operation. This will be the profiling operation, selecting each of the pockets once again. You'll see the similarities between the operations which will aid in the learning of Edgecam. We will select a tool from the tool store, filtering by ball nose, and very quickly and easily we've applied the profiling toolpath. We wish to ensure that we are error free, therefore we'll go back inside the simulation of Edgecam and allow Edgecam to take us through each of the toolpath simulations. One of the strongest features within inside Edgecam is the ability to handle design change. What we're now going to witness is the associativity of Edgecam. Moving back into Autodesk Inventor, we can interact with the original part, simply suppressing the extrusion to make a design change, save the part and move back into Edgecam. Because the solid model has been updated, Edgecam will immediately flag up that a design change has taken place. Very quickly we can see that the toolpaths have adopted the new design. I hope you've enjoyed this introductory demonstration to Edgecam. If you require any further information, please contact your local Edgecam representative. Alternatively, visit the Edgecam website. Thank you.